So MAC is also known as a cryptographic checksum. It is one of the way to provide authentication in a network where we transfer data and we implement the concept of signatures. So how MAC is calculated is on the message, the original message, or we can call as the plain text, we compute the MAC code, that is message authentication code, as MAC is equal to CK of M. Here K is the secret key, and which is being shared by both the source and the destination, and M is the original message, and C is that code, authentication code, which is used for verification. So this MAC code and the original message is appended, that is added, and that goes to the destination. That message goes to the destination. There is no encryption on the MAC. Sorry, there is no encryption on the message. So these both codes will go to the destination from the source, and the receiver, he will also compute the MAC using the same secret key. And he will also have that MAC code which is already appended with the message, and the computed code and the received code must be same. He will compare, the destination person or the recipient will compare, and if it is happening to be same, then he will accept the message. Otherwise the message will be rejected because it has not been authenticated. And there are some forms of message authentication code which you can see on the screen. That is, the first one is message authentication. There is no provision for encrypting. We don't encrypt. That's the first form. Just we are computing the MAC. In the second form, you can see from the message, again we are computing the MAC that is using a key, that is, assume K1, and both these messages appended. After that, we perform encryption on the appended message. So for encryption, we use another key. We have named it as K2. So this entire thing will go to the recipient. The recipient first, on receiving the message, will decrypt using what? The key that is used for encryption, that same symmetric key. So the K2 is also used by the recipient, and he will get what? The original message with the MAC. Again, he will compute the message authentication code for the message using the, and compute the MAC using the K1 key, because K1 key is used for computing the MAC. K2 is used for encryption and decryption. K1 is used for MAC. So you will get a result. That result will be compared with the MAC which is already been appended. If both are happens to be same, you will accept the message, the recipient, and you will, otherwise you will reject. So this is MAC authentication plus confidentiality. Okay. Now here the authentication is tied to the plain text. Now we have another option where the authentication is tied to the ciphertext. So what is that? Is the third form. A message is taken, immediately it will be encrypted using one key. Let us name it as K2. That is symmetric key. Why is symmetric key? Because both encryption and decryption uses the same key. Then after that, we compute the MAC using another key, that is a secret key. We call it as K1. And these both encrypted message and the MAC code are appended, and that goes to the recipient. Again, he will decrypt the message using K2, that is the same key that is used by sender for encryption. Then another thing is, he will compute the MAC also from the received message. And since it has the MAC code is already appended and the code, new MAC code is computed, both should happen to be same. Otherwise, he will reject. So this is the way, another form where we can tie or add the authentication with the ciphertext. In the previous case, the authentication is added to the plain text. So these are the three forms of computing the MAC. So these forms have been given as a dialogue, that is A to B. A is a source, B is a recipient. What he is sending is the simple form only for message authentication, M plus CK of M. Then the second form where we append, where we tie the authentication with the plain text. is given in the second dialog, that is A to B, and the third one we append the authentication with the ciphertext. So these are the three forms of MAC. Okay. Now, what are the advantages or what are the requirements for MAC? So, there are three important requirements. One is an MAC and a message is, if it is received by any intruder or an attacker, so he must be infeasible. It must be difficult for him to find the message with the same MAC code. In that way, we have to compute the MAC code. The second one is the MACs should be uniformly distributed. If you don't distribute like that, what happens is he may reject the message. The recipient may avoid. Okay. The third one is MAC should depend equally on all bits of the message. We should not leave even one block of code, one block of the original message. Okay, that is, these are the three requirements for the MAC. Okay, now coming to the hash function, which is also similar to the MAC, but in hash function, it is a code which is generated on a fixed size message. Okay, so H is equal to H of M. What is that H? H is a hash code. What is H of M? It is a hash function which we are performing, similar to the MAC. Okay, so these two will act as a digital signature for authentication purpose. So there are 6 forms for using the hash functions. You can see the first form, from the message an hash code is computed, and these are both are appended. Then encryption is performed on the appended message, then appended or concatenated message. Then the message goes to the recipient. He will decrypt, symmetric. See, we can see the key is K. Both sides, sender and the recipient, source and destination, uses the same key. The second form is after computing the hash code, that hash code is encrypted. So the authentication is tied to the hash code. So encryption is done. Again, the same symmetric key. The message goes there, and you will decrypt the hash code and compare it with the received or computed hash code. The third form is where we use the public key concept. That means 2 keys are involved. So when the sender encrypts the hash code using his own private key, and he gives the message to the recipient, the recipient will decrypt the hash function using the public key of user A. B will use A's public key. Okay, that is the another form. Now, third form is where the same concept, that is, after the hash code is encrypted using the private key, then again another encryption takes place using a symmetric key. So here the both symmetric key and asymmetric key concepts are involved. Cryptographic systems are involved. Then he immediately once upon receiving the message, the destination or the recipient will decrypt using the same secret key. Then he will get the message plus the hash code. From the message, he will compute the hash function, and from the hash function, he will decrypt the message because it has been encrypted. He will decrypt the message using A's or senders or source public key and compare it with the recipient. This is the fourth form. The fifth and sixth form uses a signature code which is appended along with the message. So M is taken, the original message, and a code called as a signature code is appended, and then only they compute the hash code. So we are not using encryption or decryption in this fifth form. Then the message goes, and again the message is verified, and if it is said to be same, you will accept. The sixth form is after appending the code and computing the hash function, then we are appending the message. You understand? Message is taken and a code, S signature code, is appended because it has to be verified. Then these two, from this message, hash code is computed. Then the hash code and the message is added, it is appended. Then again encryption is done, symmetric encryption. Both sides use the same key. Then the message goes there, and he will decrypt the message using the symmetric key. Then the remaining process is checking the previously, like the fifth form. See, these are the 6 forms of hash functions. So these 6 forms have been described in this picture as a dialogue. A to B. A is sender or source, and B is the destination or the recipient. So h of m is calculated, which protects the message to act as a digital signature. Okay, so these are the 6 forms. So remember, in MAC there are 3 forms, and in hash function there are 6 forms. So what are the properties of hash functions? Are hash functions produces a code, that is h is equal to h of m. It reduces the variable length message to a fixed sized code called as a fingerprint. So all these things are public key infrastructure, okay, public key management. Okay, so these are the properties, and we have got another requirements for the hash functions. That is, first requirement is any sized variable sized message m can be used, but produces fixed length output. Hash code is fixed length, original message is variable length. So it must be easy to compute h is equal to h of m. Hash code must be easily computed for the any kind of message. But h is infeasible to find. That is, x of h of x is equal to h. That is, if you want to find what is the hash code, that is h of m, it must be infeasible to find. Nobody should find what is the hash code. This is called as the one-way property. Then the fifth property is, or fifth requirement is, if you give x, that is the original message, it must be infeasible to find h of x is equal to h of y. Y is a what is that y? Another message. So it is called as weak collision resistance. Then it must be infeasible to find both x and y if h of x is equal to h of y. So that is called as the strong collision resistance. So these are the requirements for the hash functions. So this is what about the hash MAC, that is message authentication code, and hash functions. If you have any queries